Okay, today we're going to talk about tearing down a pump and maybe doing a little troubleshooting of the pump, why it failed, and then we're going to go through the dial indicator steps, impeller adjustment, and reassembly of the new mechanical seal. This is an overhung pump, bearings back here, shaft over here, so whatever we show today is going to be applicable to any style overhung pump. Much of what we show today will be applicable to between bearing pumps as well, but you just have to apply the dial indicator steps for that style pump as opposed to this style pump. So we got all the bolts loose except for this one. And by the way, I'm looking here, and the first thing that I do when I come up to a pump that's failed is I visually look in the mechanical seal area. So your old seal has a specified gap between the drive collar of the seal back here, which locks your seal to the shaft, and the back of the seal gland. And notice these are setting clips. So this seal actually is a demo seal, but your seal, the old one, the setting clips will be removed. But the first thing I look for is, did this gap change compared to whatever your mechanical seal drawing specifies? If it did, then maybe you got a bearing issue, or maybe somebody didn't tighten down the set screws adequately, or vibration caused them to back out. Okay, so here we go. I also noticed, by the way, just on this pump, this is an open style impeller, and the clearance in your I1M manual is between the front side of your impeller and the pump casing. Well, I'm noticing here a big gap, and in fact I got the feeler gauges out, and the gap is quite large. It's almost 200 thousandths of an inch. And on this style pump, you'll have to consult your own manual, but generally 10 to 20 thousandths of an inch. Definitely temperature dependent. As the metal grows, those gaps have to be opened up. Okay, all the bolts are out. We're going to hopefully drop this casing. I can clearly see inside the pump casing there's a tremendous amount of wear between the running clearance of the leading edge of this open style impeller and the casing. So really, in this case, that casing is completely shot. The impeller doesn't look terrible, but that's something to look at. Definitely no reason to rebuild this guy. All right, so next, this particular impeller is a threaded on impeller, and so you want to get the impeller off. Okay, so now we're gonna unscrew this impeller, and a lot of times they're gonna be tight because the rotation of the pump tightens the impeller, and if you've got cavitation or vibration, it's going to just tighten it more and more. So here at this shop, we make these shaft wrenches of various sizes of common pumps. This way you don't scratch up your shaft. Please don't use pipe wrench. Okay, so we put some key stock in here, put our shaft wrench on here. We're going to take this block and we're going to screw in the opposite direction of pump rotation and jam the impeller against it. Okay. That one came out amazingly easy. So we're gonna unscrew our impeller off. You see it open up maybe. Okay, and so these are the leading edges of this open style impeller. And these have to run in a close proximity to your pump casing. Otherwise you lose all kinds of efficiency and therefore flow rate. All right, now this is our stuffing box. Some people call it a rear cover. There is a gasket that seals the rear cover to the pump casing. Inspect it, no problem. Here we go. We're going to set this thing in here. It looks pretty good. So when you use a new gasket, just go ahead and put it on your parts and make sure you're not going to have any problem when you try to go together. All right, there are two little keeper nuts that hold this stuffing box in place. These are our mechanical seal bolts. What I'm going to do first is loosen the mechanical seal bolts, remove them. That way the mechanical seal will stay on the pump shaft for now. Okay, then I'm going to remove these nuts off these studs. Hold on to this in case something were to turn loose on you. Okay, and then we're going to remove this guy. Notice the mechanical seal is staying in here. This is the stuffing box. The mechanical seal gasket seals to this surface here. So it'll be critical that we look at this surface, inspect it, make sure it's in good shape. Notice also that this has a machined OD here and it has a machined ID. So while this particular mechanical seal is a shaft-centered seal, they also make seals that are stuffing box centered seals, where there's a registered pilot that goes around either the OD or a male register that goes into the bore of the box. Two different type configurations there. This, by the way, is a single standard cartridge seal, nothing special. Okay, coming off with the old seal. First thing I do is I inspect the shaft to see if there's any kind of action that might have taken place between the set screw area of the seal and the shaft, like it lost its grip and it was spinning out, or I look for the indentions, the dimples for the set screws, because what drives the seal are these set screws. They're cut point set screws that bite into the shaft. In fact, this shaft does have some evidence that in a previous life that the seal did spin out on the shaft. Either way, I look at the shaft or the pump sleeve and inspect to make sure that we've got a nice chamfer on the leading edge so that when we slide the new mechanical seal up there, it'll go on successfully, and whether or not we have any high spots or any kind of dents or variations in this shaft. Maybe it does, maybe it doesn't, but if it does, you need to replace that. Okay, so now we're kind of into our full inspection of the pump. The only thing that was a problem on this pump was the mechanical seal was leaking. We think the bearings are good, but we got to verify. If your oil is clean and clear, maybe you don't need to change bearings. If all your dial indicator readings are good, then no reason to, in my opinion. I would change your oil. You know, most manufacturers recommend oil change in your bearing housing, depending on the manufacturer, depending how hot it is, 6 to 18 months. I realize that most people don't do that, but getting some fresh oil in there, good idea. These are the dial indicator checks that should be done every time you get ready to install a mechanical seal. This particular one is where we mount the indicator in a fixed position, and we put the indicator needle on the shaft in and around where the mechanical seal is going to run, the seal faces, and then we rotate the shaft for shaft runout. We also do the same back on the back side. Many times people remove coupling hubs with hammers. That's a really bad idea. This shaft is not very big in diameter, and it is extremely easy to bend this shaft. So either put a set of pullers or use pry bars on opposite sides, but please don't use hammers to knock off your coupling hub. We also have checks for bearing fits, where we lift up and down, see if any looseness, on both ends. And then we also mount a shaft mounted indicator, pull the stuffing box in without any studs, and we sweep the face of the stuffing box to make sure that it's perfectly square with that shaft. Any angularity of your stuffing box face, like this, makes the mechanical seal every revolution of the pump work extra hard, and they'll fail quickly if you've got an out of squareness situation going on. Okay, now we're going to set up a dial indicator too. We're going to show you how to do these readings, and we're actually going to fill in the readings. Okay, so we've now got the indicator set up in a fixed position. The indicator needle is running on the shaft approximately where the mechanical seal faces are running. And we're going to fill in this value, and it's a good idea to do this on every pump you work on. That way you got a record of it, and you will catch so many things that might be wrong with the pump that you otherwise would be unaware of if you'll do these indicator steps. But anyway, we will record the inboard, which is next to the impeller, reading right here. Okay, so our indicator is on 0. We're tight here, we're tight here. I check it to make sure, pulling it just a little bit, okay? And also check to make sure my indicator needle is not bottomed out, which it is not. And I'm going to slowly rotate this thing. Make sure I rotate it 180. I'm watching the indicator. It did move some, yeah. Okay, so I'm seeing about 0.5 thousandths. The tolerance there, obviously less is better. Maybe 2 thousandths max. If it's a big diameter shaft, that tolerance may go up a tad. But on this style pump, typically I don't like to see more than 1 thousandths, but I mean, you can get away with maybe 2. Okay, we're going to take this indicator now, and while we're in this same setup, we're going to skip to this dial indicator reading right here, which checks for looseness in your housing and in your bearings. we're gonna check it on both ends. So basically, I'm gonna grab this shaft and I'm gonna pick up and down on it and see how much travel is done. So, can we see that indicator? All right, so I don't want to put so much force on there that I bend the shaft. I'm seeing next to nothing there, maybe a half thousandths. That suits me. So now we'll go to the other end of the pump and basically do the same thing. Okay, now we've got the indicator set on the outboard side of the pump. We're going to check the coupling in. And of course you got a keyway, so you can't measure in the keyway, but we start on the edge of the keyway. I've got it zeroed out. And let's see what we get. We're going to check for shaft run out. Is it straight? I don't see anything back there. Well, I do actually. My bad. Maybe a half. And oh, by the way, so on this sheet, we've written down our inboard shaft run out at a half thousandths. I'm going to write in here now the outboard run out at a half thousandths. We also wrote down the bearing fits on the inboard side at a half thousandths. With this setup here, I'm going to push back and forth on the shaft and see what we come up with on the outboard side. So our indicator, 0. A lot of times you can actually feel looseness. So when you pick up and down, if there's a thousandths and a half, 2 thousandths, 3 thousandths worth of slop between, built into your bearing or between the bearing and the housing, you can actually feel it clicking. In this case, I'm pulling back and forth on it pretty hard, and maybe I get a quarter of thousandths, but I think I'm probably bending the shaft slightly, so we got nothing there. I'm gonna write down here on the outboard side, 0 thousandths of an inch. Okay, next, we are going to take the indicator and we're gonna mount it on the shaft so that we can rotate the indicator against this surface that the mechanical seal runs up against. By the way, so all your registered fits in your pumps are very important. There's a set of dowel pins here that centers this part to the bearing housing, and then what centers this part to the stuffing box is this register right here. It's a male register, female register inside this housing. You want to check for looseness. It needs to be a snug fit. Essentially no looseness. So to do this check, I'm going to have to remove all these studs because otherwise they're going to get in the way of the indicator. Then I'm going to mount the indicator on the shaft, and we'll show you how we do that. Alright, I'm going to take this stuffing box and without the studs in, I'm going to put it back in the pump. I'm going to just lift up and down, and there's a tad of slop between the female and male register there. So I'm not going to bother taking it, but if that reading were more than 2 thousandths, one of your parts should be replaced. You want a good snug fit between the two. Okay. So we tighten up on those guys, then we're going to mount the indicator to the shaft. Okay, so now this is another step. We've shaft mounted the indicator, and our needle is on the face of the stuffing box. We've made sure that that face is cleaned up and doesn't have dents in it and things like that to where we get a true reading. We've gone ahead and pulled in this stuffing box and tightened it with these nuts here. Also, the metal to metal surface between this part and this part, if there's a bunch of crud, built up at the bottom, it can kick your stuffing box off. So make sure you clean those surfaces up before you put these two parts together to check it. But we're going to fill in the stuffing box face squareness to the shaft. Again, if it's like this and your shaft's like this, that seal's going to fail pretty quickly. So what I like to do is I'll draw myself a circle, and for you guys that are millwrights, we're going to take the face reading and the face on the stuffing box here. We're always start at 12 o'clock, 3, 6, 9. I record it as to where it is on the clock so that if I need to figure out how to adjust it to square it up, I know which way to go. Okay, so you can see our indicator here. It's set on 0. It's at 12 o'clock. What I'm going to do, and you might have to use a mirror for this, but I'm going to rotate it 90 degrees and I'm going to watch it. And there's 90 degrees. I see a half. So we were at 0 at the top. We are plus 0.5. Well, actually, let's write it in decimal so we not plus 0.0005 inches. All right, now we're going to go to 6 o'clock. And I'm going to have to get my mirror for this and my flashlight. Okay, that rascal is on 0. So we'll write that down. Sorry. Okay, we're 0 here. And we're going to go to 9 o'clock, see what we are over on this side. I'll be able to see this one. And we are -1. So we're -0.001 inches. The tolerance on this is, on this size pump, 2 to 3 thousandths maybe. And if you take 1 on the negative side and add it to a half, your total indicator reading is 1.5 thousandths of an inch. That's okay. Again, if you get a bad reading here, disassemble this part, take your stuffing box out, and those mating surfaces where it goes metal to metal, make sure they're clean, because that could be your problem. There's one final indicator step that we forgot, and we'll go ahead and just knock it out for you. Okay, and by the way, before we get off this indicator setup here, this is probably one of the more important ones, but it's one of the ones that people generally don't do. Why? Because, well, you got to remove some studs, then you got to go to the trouble of shaft mounting it, and some of these dimensions in here can be fairly tight. So what we came up with is we took a hose clamp, various sizes, and mounted an indicator holder rod right there. and you can see this, and so it does a real nice job quickly attaching your indicator to the shaft. They're also, Blom makes a nice tool, the shaft indicator holder with big chain for large diameter shafts. So, all right, we'll be back in 1 second to show you one final reading that I forgot about. Okay, so I've recorded in here the 1.5 thousandths total face reading, non-perpendicularity of the sealing surface. While you're on that indicator setup, and if you have a stuffing box large enough, and particularly on registered fit type seals, where you've got a register between the mechanical seal gland and the stuffing box that centers it, you need to reach in here and check the rim reading also. Check to make sure this stuffing box is perfectly centered with that shaft. This pump is a little bit on the small side, it's not practical, and in this case, this is a shaft centered seal. On the flange here, there's no register, there's no boss to center it up. When you install this seal, these clips here hold the rotating portion of the seal perfectly centered with a stationary portion, courtesy of the fact that these clips grab around a machine surface here. So this is a shaft centered seal. So I'm not going to take the rim reading on this pump, but particularly on bigger pumps, particularly with seals that are registered fit type centered, you need to take them. And whatever you need to do to square up that face and center it is very important. Otherwise, if it's not centered up, you can actually have contact inside the seal. Your stationary face will be out of center with respect to your shaft. You potentially could touch off and fail the seal. Okay, so in addition, the last reading that I failed to get was a thrust reading on the shaft. So we want to make sure that the thrust bearing is going to adequately hold this shaft in place during operation. So in this case, I've got an indicator set up here on the end. The indicator needle is on the shaft, and I'm going to grab the shaft without disturbing the indicator, and I'm going to pull in and out on it, try to pull the slop out of it. Now in this case, I don't have a great grip. Okay, I'm pulling towards me, pushing away. I see a 1/2 thousandths. So I'm going to record that. That sounds good. Okay. Shaft in play. Thousandths of an inch. All right, so now we pretty much got everything done on our readings. We've got run out of the shaft inboard, 1/2 thousandths. Run out on this end, again, 1/2 thousandths. Shaft is pretty doggone straight. Then here you've got face squareness, total, negative plus positive, 1/1000ths. This shows a setup for taking the rim reading, concentricity of the stuffing box with respect to the shaft. We did not take that reading just simply because of the size of the pump and we got a shaft centered seal. Then here are the bearing fits. We got a 1/2 thousandths on the inboard side, and we got 0 thousandths on the outboard. Good tight bearings. Then here we filled in a 1/2 thousandths, and that's for shaft in play. Now, I'm going to fill out the date, the customer, various information, the pump model, serial number. I'm going to date it. I'm going to sign it. Obviously, if there are any problems that you encounter, fix them before you go spending the money to put in an expensive mechanical seal. Then we actually scan this and put it in our computer for records that we can lean back on when we talk to our client about any issues that they might have with the pump that we've had our hands on. pretty rare that happens. And it'll be very rare for you that it happens if you do these, if you take these steps. This will eliminate easily 98% of pump-related issues. Now, we still got a ways to go on proper installation of the seal and setting of the seal, but this is most of it. By the way, you know, I talked about a shaft-centered seal versus a stuffing box-centered seal. Well, this actually shows a stuffing box-centered seal. Here's your stuffing box right here. There's your pump shaft. This whole deal here is the cartridge seal. And notice this male lip, this male register that goes in the bore of the stuffing box. So that's what centers that seal. Notice the setting devices are simply washers that roll into a groove in the sleeve. So when you work on any seal, get your drawing out and figure out, is it shaft centered? Is it stuffing box centered? How do my setting clips work? Do they grip the outside of a metal surface, or do they go in a slide, etc.? This is a drawing of a shaft centered seal. Notice that there is no lip between the seal gland and the stuffing box, which is right here. Of course, pump shaft here. And also notice that the setting clips, they're mounted on the drive collar, actually grip around a machine surface on the back of the gland. When you troubleshoot seals, you get a work order that says, hey, go replace seal on ABC pump. Again, first thing I do is I look to see if they have the proper gap between the drive collar and the gland. We talked about it earlier. That's a place where, you know, if a guy gets busy or doesn't pay attention, he doesn't properly tighten them down, or maybe he tightens them down, takes the clips off, and then he adjusts the impeller. No. Adjust the impeller with the clips in place. Do not secure the seal to the shaft. The last thing you do is set that seal to the shaft and remove whatever setting device is on that particular design of seal. Okay, so next step, I'm going to put my studs back in. I'm going to pull all these indicators off. We're going to put in the new mechanical seal. Okay, so now we got our new mechanical seal. Open up the box. In every mechanical seal, generally there's going to be a mechanical seal drawing in there. It tells you what pump it fits. It gives you all the dimensions of the shaft. The stuffing box board gives you a lot of helpful information. Generally speaking, it'll have a bill of material over here. It'll tell you the materials of the seal that you're getting ready to install. This is a mechanical seal. It's got various cautionary notes on it. You know, take note of them. Read every one of them. This seals, it says it's been tested at the factory to 25 psi. They put this on a mandrel. They put clean compressed air to it, and they shut it off, and they make sure that it doesn't leak down too fast. So it passed. Then they got various shipping plugs in here. Notice here, now this is something that people run into all the time. They call me and they say, well, what are all these ports on here? Well, go to your mechanical seal drawing, and it'll show you a picture of the end view of the gland, and it'll tell you which one is the flush port, which one is the quench port, which one is the drain port. Sometimes they have a vent port. This one has 3 ports, drilled in tap ports. On your drawing, you'll see this is the flush port. Flush means that the fluid goes into the process. The
quench port and the drain port, well, the drain, that's pretty self-explanatory. If your seal leaks, you want it coming out your drain port rather than coming out the back and slinging all over the place. The quench port is also on the atmospheric side, so both the quench and the drain are on the air side of the mechanical seal faces. So, and this happens all the time, if you hook up your flush water to the quench port or the drain port, seal's gonna spray all over the place. So just take note of which ports are what. So we'll remove these shipping plugs, keep everything clean. They've got a warning decal that says this is where you have to tighten the drive collar to the shaft. I'm going to go ahead and remove this because we're going to basically go through a full installation on a brand new seal. All right, first thing I do is I check very closely back here these drive lugs. You know, the guy at the factory, hopefully he was on his game that day, and hopefully he's got these things properly secured. Well, so I get an Allen wrench and I look at it, make sure everything looks good. I come up to these little setting clip devices, make sure they're good and snug, because if they're not good and snug, then they won't properly center things. Okay, everybody's good and snug. And then I'll look at the set screws that are going to bite down in the shaft. Now in this case, there are 4 of them, 4 cut point set screws. Bear in mind, there are also 2 locator set screws. These are at 180 apart. Don't mess with those. Those, as the guy's assembling them, he just snugs those down, barely, to locate the drive collar. You do not need to tighten these to the shaft. You tighten the cut point set screws in the case of these standard cartridge seals that bite down to the shaft. There are various mechanisms as far as securing the rotating portion of the seal to the shaft. They have shrink discs, they have ring fetters, they have set screw driven collars. This is the most common. I check to make sure that the set screws are backed out enough to where when this one's in just close, I'm gonna back it out just a little bit to make sure that when I slide this thing up on the shaft, it doesn't touch off. Check your gasket on this side, make sure it's fully seated in this metal here. A lot of times they'll have a female register here where the gasket will stay centered. Here's your O-ring that seals to the pump shaft when we install it. It'll be installed like so. I put a compatible grease on that O-ring, lube it up. I keep the shaft clean. Okay. And by the way, make a habit of installing the mechanical seal on the shaft. Don't do like has been done on some occasions and install this seal and tighten down on it, because look at this. This is a shaft centered seal, but look what I can do. See how it'll move all over the place? So if you tighten it down here, it's going to be out of center. So the proper method is to put it on the shaft. And so I'm going to go ahead and install this. Now, bear in mind the quench port, look on your seal drawing, but it's normally at 12 o'clock. Okay? We're going to lubricate the O-ring a little bit. And install this guy. I got my quench port at 12. Okay. So there's the seal on there. Now we're ready for our stuffing box. goes with the nuts. Okay. Go ahead and snug those up. Okay, now we grab our nuts that are going to secure our seal and our washers. Put these nuts on. And at this point, this is a shaft-centered seal. And so it's okay to go ahead and tighten the seal gland to the stuffing box. What we don't want to do is we don't want to tighten the set screws to the shaft, because once we assemble the casing, put the impeller on, we're going to adjust the impeller clearance. So the last thing you do is tighten down on those, in this case, 4 set screws, remove the clips, and you're ready to run. So I'm going to go ahead and tighten these nuts. And then I'll come back, we'll put the impeller on, we'll do the clearance. Okay, so I got my seal up here, snugged down by hand to the stuffing box. This is a Teflon gasket that we're compressing between these two surfaces. So while we've done the dial indicator reading to make sure that our face reading is good, if we tighten down this gasket too much, we can. So you want to do it evenly. You want to bring it up slowly. You want to cross 180 from one bolt to the next. And for instance, if it's Teflon, you just want to tighten it enough to where you're going to get a good seal. There's no reason to extrude the Teflon out to where the gasket's completely shot. So we got this guy tight. All right, so our impeller has a O-ring in this case that seals to the pump shaft here, threaded here. So this O-ring's bad, but obviously you'll want to use a new O-ring every time. Little anti-seize here. Don't get the anti-seize anywhere near the seal. Seal faces do not like anti-seize. Anti-seize here. Put the impeller on. Turn the shaft in the direction that the pump's going to rotate. Okay, and then we use our shaft wrench to fully tighten the impeller, because before we go adjusting that impeller, we want to make sure we're good and tight. And the way we do it is we'll put this on a metal table, and imagine that this metal comes out to here. And we'll take this impeller and we will, in this case, let's see. Yeah, actually it'll go like this, sorry. So it'll come over here, boom, and we slam it down on the table. The guys in the shop call them slam wrenches for that reason. But anyway, so we get this guy fully tightened. Notice we still hadn't tightened down our set screws. So then we're off to putting the back pull-out assembly in the pump in case you left the casing in the field, or if you brought the whole pump back to your shop, installing the case. This is pretty heavy. Get the bolt in here. started, and by the way, it really helps to have this pump when you're doing this step on a flat table. Now this table is not flat, but if you've got a granite rock that's been polished off flat, that's what we assemble them on. Because that way, the bottom of your machine pump casing feet and your bearing housing feet will be parallel with one another. Minimize any chance of any soft foot when you go to mounting this pump on the base plate. All right, so bottom line, put all these guys in. Again, we tighten them up gradually crosswise. We're compressing a gasket, important that it's even. And then we're gonna adjust the impeller. So this little deal back here on this style pump has a thrust bearing carrier here, excuse me, that has 3 pull bolts that pulls the housing this way and 3 push bolts with lock nuts on there. So this is a slip fit between this part and that part, so bear in mind that if you over tighten one side, you can actually cock the housing in here. And I've actually seen people to where they are not paying attention and they actually lock the bearing up, because the internal clearances on the bearing are very little. This pump is a little different in that here's your housing here, and this is a machined thread between this bearing housing here and this larger housing. So in this case, it doesn't have any push bolts, pull bolts. It has 3 little keeper bolts that once you get the impeller set to the right place, then you snug those up and that's it. The cool thing about this is, because it's threaded, there's no, or the potential for putting a bearing in a bind or misalignment is minimized. Another feature, you know, we talked about this guy being an open impeller pump. Well, in this case, here's your impeller in this pump, and this is a radial clearance between the mouth ring of the casing and the impeller, and then this is a front shroud. Well, it's open on the back side in this case. So the running clearance is between, on this pump, between the back side of the impeller and the stuffing box. Okay, just consult your manual to figure out, you know, what you got and what you don't have. So the first step, we've already verified we've got over 200 thousandths worth of the first step is to get this to where my pull bolts can pull everything forward and we can set it properly. Okay, so I want to back these guys out pretty much all the way. They're the push bolts that push it this way. Okay. Okay, so what I'm going to do is I'm going to tighten one of these screws until it starts touching off. I'm going to be rotating the shaft. That little noise you're hearing is actually the shaft turning inside the mechanical seal. All right, Well, look, our gap between the leading edge of this housing and this is almost completely gone. So I'm probably not gonna be able to adjust it to the correct running clearance. As I say, that casing's completely worn out. But I pull it forward and till I scrub, and then I barely back off. So we pulled it forward, and imagine now that it's scrubbing, and we're gonna back it off. And what helps too is to have a dial indicator for this step, just like so. Because once we're scrubbing, that's our 0, and then we back it out whatever the manual says, and then we lock it. So, since we're scrubbing, we're gonna now back it out. All right, set our indicator at 0. And so we use one of these jack bolts, push bolts, and we, again, imagine we're touching off down here. So we're gonna pull everything this way. All right, here we go. There's 10 thousandths. Let's assume your manual calls for 15. We're going to set it to 15. Boom, 15. Make sure everything turns free. Then we're going to take these other push bolts and we're going to run them up to where they just barely touch off. Literally by hand is the best method because you don't want to move the shaft. Okay, it's touching off. This way. Oops, back that nut out a little more. Okay. Now, we want to very evenly snug up on the pull bolts. Now I'm gonna barely snug back up on these guys. I want to make sure I don't have any play. Okay. Check this one more time. Yep. I don't want to go crazy on tightness there because, like I say, you can lock it back. All right, and then these little jam nuts, run them down, snug them up. You're good. You're ready to go. So the seal is tight to the stuffing box. Imagine that all these bolts are pulled in and fully compressed. We've set the impeller clearance. So we're ready to go. Now let's set our seal to the shaft. So this seal here, there's one of the set screws. And now bear in mind, this is the only thing holding this seal to the shaft. So these set screws that I'm getting ready to tighten need to be really tight. Because if your set screws lose their grip, what will happen is the pressure in the pump it'll cause the seal sleeve to start spinning on the pump shaft, and it'll also, the pressure will push the drive collar back, and this gap here will open up to a larger gap than what it should be. And what that does is over compress the seal faces. The seal faces lose their lubrication, heat up, break, you're right back in your pump. Okay, so we're gonna go around here, we're gonna tighten all these guys up. I'm gonna get a pair of channel locks, to give me some extra oomph. I'm gonna tighten them even. And once I got them all tightened, then we remove these clips. Your seal is now locked to your shaft. Okay, so and by the way, notice you see that the width of that piece right there. That is the dimension on this steel between the back of the gland and the drive collar. And in this case, that gap should be 62 thousandths of an inch. So again, if you come up to a seal and the seal has failed and that gap's bigger than what it should be, then that's a serious factor. All right, so we're going to go ahead and remove all these clips. The very last thing, I guess, is thinking about a seal flush. So, depending on the design of the stuffing box, depending on the service you got, we got all different kinds of seal flush plans. We have a booklet that shows what seal plan they assign API flush numbers to it. A very common one is a plan 11, where you come off with discharge pressure. In this case, we would have a drilled in tap port here. You screw in an orifice to control the pressure and the flow rate being delivered to the seal, and you flush in with high pressure fluid. Consult your seal supplier as to what flush plan they recommend. Many times, if it's a customized drawing, it'll say over here what flush plan to use. In this case, this is a generic seal that fits all different kinds of 1 3/4 shafts. It's not application specific, so there's no flush plan indicated here. But you need to think about a flush plan. If you just plug all these ports, or plug the flush port, then there's really no circulation of the fluid back at your seal faces, so it builds up heat. Will it survive like that? Yeah, I mean, I've seen tons of seals out there that run with no flush plan. Depending on the style stuffing box that the pump manufacturer has, if it's a taper bore stuffing box, then fluid can come in the seal area and go out. So you do get some flow and you don't necessarily require cooling. Here's another example here. Here's a taper bore stuffing box with little speed bumps, and that minimizes the amount of swirling that the fluid does back here, because if you're pumping a lot of solids, it can erode this part. So those speed bumps knock that out. But this is a self-venting. See how the bore down there here is smaller than here. So any air bubbles when you initially flood the pump are going to go out. And also, fluid is able to come in the seal chamber area, cool the seal faces, which in this case are right there, and then go back out. This style impeller has balance holes in it. So fluid comes in here at suction pressure. Through centrifugal force, the pressure is increased. Then high pressure fluid comes on the back side of the impeller. This is the running clearance in this pump between the back side of the impeller and the stuffing box. And so then you've got pressure somewhere in between suction pressure and discharge pressure coming into the seal chamber. And then these are balance holes which allow that fluid to go back to suction pressure. So you're getting plenty of flow back there in that case. Hot water is a unique situation. Any fluid that's close to its vaporization point, basically a mechanical seal, the essence of a mechanical seal, whether or not it's going to last at all, is the fluid film in between your seal faces. If that goes from a fluid to a gas, i.e. it flashes, boils, that's gonna do damage to your seal faces. So maintaining a stuffing box pressure of at least 25 PSI over the vapor pressure of your fluid is a rule of thumb. If you're running carbon against silicon carbide, for instance, that's more tolerant of being on the edge of flashing compared to silicon on silicon, say for instance, if you're dealing with a slurry seal. Okay, that's about it. Hope this was helpful. Thank you.